All right. Good afternoon to you guys. How was your first week of classes? Medyo, I imagine magaan pa yung first week, no? Kasi puro orientation and introductions muna. Pero I don't know, but we are making good progress with the course outline already. So I hope you guys are starting to get the feel of or the acad feel back after yung medyo mahaba-haba nating bakasyon. So we had some headway last time. We talked about, or we started talking about a reconstruction of the set of real numbers from scratch. Remember from last time, nagsimula tayo, or we said na ang goal natin for the first chapter of Math 155 is to rebuild the real number systems axiomatically. So hindi katulad ng pragmatic approach na ginawa natin during our early elementary mathematics or your college or high school algebra, wherein you started with a notion of these numbers plus how to perform some operations on them. Ngayon medyo baligtad kasi axiomatic yung gagamitin nating ruta para makuha uli yung set of real numbers. So as in any axiomatic or mathematical system, we started with some undefined terms, and the very first one is the set of real numbers itself. So sinabi natin, okay, pagpalagay na meron tayong set of real numbers. But the funny thing about that is we don't know what these real numbers are, right? Nagsimula tayo, okay, meron akong set, tatawagin ko siyang set of real numbers, yung laman niya ay mga real numbers, pero wala tayong binigay na example. Ano yung laman ng mga real numbers na to? Ano yung properties na dapat naman ng isang object para maituring na isa siyang real number? So it's just about an abstract concept. And I said it's not a pragmatic view or a pragmatic construction kasi nga titingnan natin, mag-i-impose tayo ng mga properties na dapat masatisfy ng set of real numbers along with two binary operations, which are also undefined so far. So aside from set of real numbers, dinagdagan ko pa yung medyo abstract nating isipin. Sinabi ko, kunwari, meron akong dalawang binary operations. And by binary operation, I mean, these are operations that take as input two real numbers and give us back another real number. And arbitrarily, I just call this addition and multiplication. Pero hindi ko pa sa inyo itinuro paano mag-perform ng addition at multiplication. Remember, I requested you to forget all of the things you know about real numbers before kasi nga inassume natin na we are going from a blank slate. All right? So ito yung mga undefined terms. Meron tayong set of objects under consideration. We have rules called addition and multiplication on how to play with these real numbers. And and then now we started imposing some of the properties. Ano yung mga properties na gusto nating mapossess ng ating imagined set R under the two operations, addition and multiplication. And along the process, we met the first two real numbers in our system. All right. Remember, meron tayong algebraic, or what I also refer to as the field axioms, A1 until A9. All right. Kung natatandaan nyo yung sabi natin, addition and multiplication are binary operations on R so that they satisfy A1 to A9. Ano-ano yun? Dapat commutative yung addition. Pagka binagbaliktad ko yung addends o yung terms dun sa addition, I should get the same sum, all right? Or the same result after the addition. Addition should be associative, and then these two properties are also the same for multiplication. And then we have identities for both operation. We said na may nag-exist na real number such that kapag ka inad ko siya sa kahit na ano pang real number, makukuha ko pabalik yung original real number. So there exists a real number, and out of the blue, arbitrarily, I'm gonna call it 0. All right? So si 0, na isang real number, siya yung mag-act as additive identity in such a way that for any real number a plus 0 is equal to 0 plus a will retain to be a, or will remain to be a. Right? So ito yung additive identity, and this is the first real number that we have met. So, inassign ko yung symbol na 0 o yung name na 0 para doon sa additive identity. Additive identity because it doesn't affect the identity of a real number after we operated on it with 0 under addition. Okay? And in the same manner, may pinakilala pa akong isang real number, and that real number, I arbitrarily called it 1 and assigned this notation. For that number, this will act as the multiplicative inverse in the sense that kapag ka minultiply ko siya, either to the left or to the right, ng kahit anong real number, I will get the real number back, right? So yun yung definition ng multiplicative identity. It preserves the identity of any real number after multiplication, right? And that's what I'm saying. We only know so far dalawang real numbers, si 0 at saka si 1. So we can call them 0 and 1 now kasi pinangalanan natin sila. But in essence or in abstract sense, they are just the additive and multiplicative identities respectively. All right? So that's A3 and A6, I think. And then we have A4, the existence of an additive identity for every real number. So that means for any real number A, there exists a real number denoted by negative A, such that A plus negative A is equal to the multiplicative identity. Now, there's a bit of abuse of notation here. I'm calling this negative A, but in fact, we don't know what the what being a negative number is, right? So that's why it is more rightfully called the additive inverse of A. Though it's a bit of a mouthful kung sasabihin ko siya paulit-ulit, kaya minsan negative A yung basa ko sa kanya. Because remember, we don't know what the real numbers are. So we don't even know kung ano yung positive at saka negative real number. Hindi pa natin sila na-define. So for now, if you see a negative A like this, we won't think of it as the negative numbers kasi kinalimutan nga natin yon. Babasahin natin siya or i-interpret natin siya as the additive inverse of A. Meaning, this real number is what is to be added to the number A so that we get the additive identity back. All right? So notation lang to para sa additive identity. And then we also said we have a multiplicative identity, but not for everyone. All right. So there exists a multiplicative identity for every real number except the additive identity. Yung additive identity, which we named 0, wala siyang multiplicative inverse. But everything else, any other real number, we want to have a multiplicative inverse. So we say that for all real number A not equal to the additive identity, there exists a multiplicative inverse, which we will denote by either a to the minus 1 or 1 over a. So that's an alternative notation, all right? So do not think of it as exponentiation because we haven't defined what exponentiation is or how it is done. Do not think of 1 over a as a fraction kasi wala pa tayong notion ng fraction. So we think of it as the multiplicative inverse of A. What is to be multiplied to A to get back the multiplicative identity? So this is a real number such that A inverse times A is equal to 1. The multiplicative identity. And you see how abstract these things are. Pag pinalitan natin si A o kaya si 1 at saka si 0 by any other symbol, all of the theory is still retained. So it's just about naming things and conventions. Pero tinawag natin siya in that way para maging parallel siya dun sa alam na nating real number system. Okay? And then those are the 8 first axioms for the set we have. And then we introduced A9, which is a distributive property of multiplication over addition, which kind of ties up the two operations together. So A1 to A9 are what we call the algebraic axioms or the field axioms for the set of real numbers. Because so math 111 or some modern algebra, kahit anong structure, meaning a set together with two binary operations satisfying A1 until A9 is called a field. And the set of real numbers is a nice example of a nicely behaved field. All right? So kaya field axioms yung tawag natin sa kanila. And then we ended last time by I think by stating some very basic inherent truths about equality: reflexivity, symmetry, transitivity, the multiplication and addition properties of equality. Tama nga ba? Doon tayo natapos last time. Haba lagi ng recall ko, no? 10 minutes. But are you guys there? Or nag-ano lang ako, nag-sign ako ng laway for 10 minutes. Hopefully naririnig niyo ako. Thumbs up or react naman if you're there and you can hear me. Okay, thank you guys. Any questions or clarifications about that? Yun. Yan yung ginawa natin last time. So I guess we can go on and probe these properties further and look at what are the consequences of these axioms. So these are the first few results that we can deduce from these axioms that we have laid down. Okay. Now, the first thing that you will notice is medyo kakaiba pa rin tong system natin so far with what we know from elementary. Kasi sa elementary, meron tayong 4 basic operations. But it seems that by the way I constructed R in section 1.1, we only needed 2 undefined operations or 2 abstract operations. Now, where will the other 2 operations come from? Well, what we know as subtraction and division are actually variants of addition and multiplications. Multiplication. That's why meron lang tayong dalawang basic operation talaga. The other 2 are just special cases of these 2 operations. So for instance, in definition 1.1, we see that subtraction of 2 real numbers is basically an addition in disguise. We write a minus b to mean that we are adding to A the additive inverse of negative B. All right? So yung A minus B talaga, siya talaga ay A plus additive inverse of B. And in the same manner, whenever B is not equal to 0, we can define an operation which we can call division, all right, by using the undefined term multiplication or the undefined operation multiplication. Assuming that we know multiplication, then we can perform division by simply treating A divided by B or A over B as simply a multiplication of A by the multiplicative inverse of B. And that's why the assumption that B is not equal to 0 is important. Because if B is not equal to 0, division doesn't make sense because division requires multiplication by the multiplicative inverse of the divisor. Okay? So kaya as we go along, parang dalawang operations lang lagi. Sa mga proofs, sa mga theorems, laging dalawang operations lang yung pinag-uusapan natin. Kasi nga, you can directly or you can in a straightforward fashion deduce the same properties for subtraction and division. Okay? Which brings us to our very first theorem, the cancellation law for addition. And this is a very important tool. Ginagamit natin to since elementary. Yung mga suki ng quiz binon, alam na alam nyo to, right? From an early age. Now, but we never question bakit siya nangyayari. Or it seems to be very natural, all right? Pero bakit? We need to prove it because of because the meta axiom of ignorance tells us na bawal mong gamitin ang isang result, however obvious it is, unless it is a definition, it is an axiom, or it is a proven result. So in order to capitalize with this seemingly very obvious and very inherently true result, i-prove na natin siya para from now on, we can use the cancellation law for addition. Okay? Now, the first few theorems, I'll treat them as a review of Math 101 or proof techniques. Kung nakalimutan nyo na, you need to brush up on these techniques na gagamitin natin. So I'll use this class para doon. So pardon kung medyo mabagal yung gagawin kong discussion sa methods of proof. Unless you guys can tell me now na, sir, bilisan na natin yung proof. Magaling po kaming mag-prove so we can go and focus more on the results themselves. But again, these results are very, very elementary So ang utility talaga nila or yung significance nila in our discussion is a review of the proof techniques. Because in the entirety of Math 155, our bread and butter would be on proving things. So kaya importante na matandaan natin, ma-recall natin yung mga iba't ibang posibleng ways of proving statements. Okay? Now, let's go to a cancellation law. What does it say? It says that if we have three real numbers, A, B, and C, and we know that A plus C is equal to B plus C, then we can conclude right away that A is equal to B. Okay? So this is what we call a conditional statement, an if-then statement. And usually to prove if-then statements, we use a conditional proof. A conditional proof allows us to make use of the premises, or other terms for this would be the precedents or the antecedents. Okay, pwede mo silang i-treat as assumptions kasi kapag ka nangyari to, then mangyayari yung nasa then part. So in our proof, we can assume that the if part already occurred or that the if part are true. Ito lang yung mga pwede nating gamitin na assumptions dun sa ating proof, together with all other previously known results or previously proven results. And then the goal is to show that assuming this, we'll get A equals B using logical arguments. So yun yung gagawin nating proof. So that's what we call the conditional proof, and sometimes it's called the direct proof for conditional statements. Direct in a sense that, kasi symbolically, this statement is of the form P implies Q. A direct proof will start from P, assuming P is true, and then use logical arguments in order to arrive at the statement Q. All right, so yun yung itatry natin gawin. And then this is one mode of proof analysis that I will use throughout the course. Dun sa lecture notes, marami ng proofs na nakasulat. So isang method na pwede kong gawin ay daanan natin yung proof line by line. Okay, hindi ko siya isusulat from scratch. I will just read the proof with you guys, and then let's analyze it sentence by sentence, insert some details if needed, or analyze bakit niya nasabi yung sumunod na line. Bakit nag-follow yung line na to from the previous lines? Ano yung reasons behind those steps? All right, and this is a nice skill to have, all right, or to get used to, lalo na pag nagme-major na kayo, may mga books, babasahin niyo yung mga theorems, nandun na yung proofs, then para masanay kayo mag-prove, sometimes it's nice to analyze the written proofs, insert the details, so that pag kayo na yung mag-prove on your own, medyo meron kayong makakapag-develop kayo ng instinct kung ano ba yung susunod na gagawin, ano yung mga posibleng atake dun sa proof, or ano yung mga preliminary steps to be taken. All right? Now, let's go to the proof. Now, it's a conditional direct proof. So we will use the assumptions. So I will assume that A, B, and C are real numbers and that A plus C is equal to B plus C. Now, I can use this kasi nandun siya sa if part. Part siya nung premises, part siya nung precedent o nung antecedent nung conditional statement. And then coming from these two premises, I will use logical arguments, meaning I'm going to use logic tools. So kailangan i-assume nyo ngayon na yung first order predicate logic and propositional calculus ay tandaan nyo pa, gagamitin natin sila. At saka yung mga previously known results, the axioms, the undefined terms, and the theorems. Okay? Now, tingnan natin yung kung ano yung ginawa ng proof. Well, starting from here, since I know these two guys are equal, I can add whatever I want to both sides. And that's what we call, ano ang tawag sa property na yun? So I'm trying to put down a reason for this line. Why am I allowed to add a negative C to both sides of this premise? Anyone? So if you want to recite, just raise your hand. Tapos pag na-recognize ko kayo, you can either unmute yourself or type your answer in the chat box. All right, any volunteer? Sayang yung mga tiny bonus points. So, any volunteers? Ano yung reason for that first line? Ano yung susulat ko dito sa by? Sayang wala pala akong kape habang nag-aantay ng sasagot, no? But, Jonathan said substitution. Not quite right. So try again, Jonathan. Si Charles, hindi pa raw memorize yung actions. Pwedeng hindi naman eksaktong pangalan o hindi kailangan yung number ng action. Basta ano yung pwede nyo ikwento kung ano yung property. So hindi kailangan yung exact title. Nerissa said conjunction. Not quite. So try again. So remember, nagsimula ako dito. Okay? Tapos sinabi ko, okay, ito yung gusto kong gawin. Ano ba nangyari dito? Ano yung pinagkaiba nung original premise with the first line in the proof? Well, what happened there is nagdagdag lang ako ng negative C to both sides. And yeah, I think Lester got it on the chat. Yeah, addition property of equality yung ginamit ko rito. By the way, nabasa na ba natin yung APE last time? Baka kaya hindi nyo tanda yung pangalan, hindi pa natin siya nabasa. Tinakluban ko kasi siya nitong sinulat ko kanina. So ito, yung equality properties. Yan, quality properties. That's theorem 4. Okay? Or equality property number 4, which is one of the axioms. Addition property of equality. Ibig sabihin, kapag meron kang dalawang equal na quantities, then you are free to add the same thing to both sides of the equality and you will preserve the equality, right? Dalawang equal na bagay, dagdagan mo sila ng parehas na bagay, yung dalawang sums ay equal pa rin sa isa't isa. So addition property of equality. All right, thank you, Lester. Yeah, that's APE. And then I was, or the lecture note was very careful in applying the APE. Kung matatandaan niyo yung APE, okay, balikan nga natin yung APE. Okay, yung APE, ito yung sinabi niyo. Okay. Nagsimula ka sa dalawang equal na bagay, nagdagdag siya ng C dun sa kaliwa, or sorry, dun sa kanan ng A at saka ni B, and the equality is preserved. Now, if you want to apply the APE, yung APE lang, as it is stated, dapat magdadagdag ka ng isang real number dun sa kanan, ng dalawang numbers A and B. However, we know that addition is commutative, so medyo relax tayo kahit saan ka mag-add sa kaliwa or sa kanan. Pero to be faithful to the text of APE, ang gagamitin natin ay mag-add lang ako sa kanan. Kung napa-add ako sa kaliwa, mag-add ako sa, mag-add ako sa kanan. Kung nag-add ako sa kaliwa, yung reason ko, hindi lang APE. Ginamit ko si APE as stated in the lecture note, plus I used commutativity. All right? Then another thing that the lecture note was careful about is the grouping. Okay? Remember, addition is a binary operation. Dalawa lang at a time ang pwedeng mag-undergo ng addition. Alright? So, hindi pwedeng tatlong sabay-sabay ipag-add kasi by definition, addition is a binary operation. Remember, by our convention earlier. Now, that won't be a big problem because A plus C on itself is a real number. A plus C is the sum of A and C. It's another real number, all right? So this guy can be taken off as a single quantity. Kaya in-enclose siya sa parentheses, okay? And then, nagamit ko pa pala yung APE because I know that negative C is a real number. Since C is a real number, I am sure that that real number C will have an additive inverse denoted by negative C, okay? So if you want to be very meticulous or detailed about it, you can put AP and the existence of additive identity. I think that's A4 dun sa mga actions, mga field actions natin, right? But again, in your work, pag nagpo-prove kayo or nagpapasa kayo, pwedeng hindi yung actual title yung sabihin nyo or yung actual number yung sabihin nyo, right? Just a brief description or a common name for the property, that's fine, okay? Gamitin ko lang A4 kasi tanda ko pa yung numbering, saka medyo Saka medyo madali pa siyang tandaan. Oh yeah, yes, Charles. Existence of additive inverse. Ano ba sinabi ko kanina? Additive identity ba? Right. So existence of additive inverse for any real number. Thank you, Charles. Okay, so that's it. And then what happened to the next line? Ano yung reason? Ano ba yung nangyari sa susunod na line? Mukhang ginulog-gulog yung parentheses. So what's the property there? Okay, yeah, Matthew and Charles are correct. That's associativity. So you can put associativity of addition, okay? Or you can say it's A2. A2 yata yung pangalan niya. So, but you don't need to memorize those numbers. You can just give me a title or a description of the property. All right? But just be careful. Just mention kung ano yung operation. Kasi may dalawa tayong operations na pinag-uusapan dito. So, to remove any vagueness, so sabihin natin associativity nino yung ginamit. All right? Then guys, if you want, I think it's better if you unmute yourselves kesa sa chat. But kung hindi kayo makapag-open ng mic or wala kayong microphone, that's fine. Keep on doing the chat. But if you can, it would be better and I'll appreciate it more if you will unmute yourself. All right? Okay, no problem, Charles. That's fine. I understand. So kung wala talaga, sige, chat na lang. Pero mas okay sana kung may kausap ako dito, no? All right, so next line. Okay, mula dun sa associativity, ni-readjust lang yung grouping. Kaya lang biglang may nag-pop up na mga zeros dito. What happened? Ano yung reason sa susunod na line? Okay, you can type your answers in the chat box or better yet, raise your hand and then I'm gonna call you. And then usually priority ko muna yung mga hindi pa napag-recite para lahat may opportunity to garner some recitation points. By the way, you'll get only 1 point per day. So pero you are encouraged to participate more than once. Pero to give everyone a fair chance. So yeah. Okay, what happened? Gian says A4 additive inverse of C in this case. Yeah, that's correct. Thank you, Gian. Yeah, tama. Nangyari sa susunod ay by the property of additive inverses. By property of additive inverses. I will also accept kung sabihin nyo ay A4. Okay? Yung existence ng additive inverse. Kasi nga, by definition, by our notation, si negative C siya yung additive inverse ni C. And by definition of an additive inverse, pag inad ko yung additive inverse, dun sa ka-inverse niya, ang sagot ay si additive identity, which is 0. And isn't it cool na kahit hindi pa natin alam kung paano talaga nag-a-add or hindi pa natin kilala ano yung mga real number, by the properties that we laid down before, by the field axioms that we have enumerated before, we know na pag nakakita ko ng C plus negative C, ang sagot lagi ay yung additive identity 0. It doesn't matter what C is. Even if it's a cow or if it's a bird, it's a crow or it's an ostrich, okay? So kapag inad ko siya sa inverse niya, sure ako ang sagot ay additive identity. All right, and that's what happened in here. And then, so remember, what's our goal? We want to we want to reach the conclusion of the theorem. So we want to get A equals B. And finally, here, nakuha na natin yung A equals B. But how did we get there? Coming from here. Ano yung reason? Why were we able to conclude A is equal to B? Okay, Rezi? A3. Jonathan had the same idea, existence of additive identity, right? Because 0 acts as the additive identity. And by definition, yung additive identity, wala siyang epekto dun sa identity nung real number kung kanino mo siya inad. So I can say by A3 or you can say by property of 0 as the additive identity. Okay? And that ends the proof. One of the most satisfying thing for a math major, drawing a square box, shading it out, end of proof. Okay? So yun yung example ng conditional proof. Okay? Any questions with this? In the first homework, I'm gonna ask you to write a proof similar to this, line by line. Lalagyan nyo ng reason, just to familiarize us paano magsulat ng proof. Pero siguro later we'll go away with the formalities and the details. But for now, let's practice this one. All right. Pwede rin QED, quod erat demonstrandum, Charles. That's fine. However you like to end the proof. Do medyo antiquated na yung QED, right? So medyo lumang panahon yung QED. Pero yeah, that's also fine. Yeah. Okay. All right. Any questions? Everything's clear? So hopefully na-recall kung paano magsulat ng proof. Okay. Now, the other method of analysis or proof analysis that we'll use throughout the course is to write the proof from scratch. Okay. So, minsan may mga exercises na gusto kong sagutan kasi baka makapagbigay sa atin ng insight yung mga proofs, right? So, sometimes sila yung madadali, minsan sila rin yung mahirap. So, tulungan niyo ako mag-isip paano isusulat yung proof. But I guess the proof for the cancellation law for multiplication will be very similar to the proof of the one for addition. Okay. Now let's see what is the assumption here, or what are the assumptions here. Now in this theorem, we will assume that A, B, and C are non-zero real numbers. Take note, dapat non-zero silang tatlo. And aside from that, we will assume that AC is equal to BC. And then we want to show that A is equal to B. Now, it's again another conditional statement, and I guess a direct proof will suffice for this one. I will assume these conclusions and hopefully come up with A equals B. Okay? Now, let's try to do the proof. So we let A, B, and C be real numbers, so you can write that here. Or you can just say, sir, nandun na siya sa taas, so pwede nyo na rin hindi siya isulat. But I'll just write it here just for emphasis. So they are three real numbers not equal to 0. Okay? And moreover, we start with AC equals BC. It is fine to start with this identity because it is part of the if clause. Isa siyang antecedent. So pwede ko siyang gamitin anywhere in the proof of the conditional statement. Our goal, we want to show that A is equal to B. Okay? Now think back to the proof of theorem 1.1. And that will tell you ano kaya yung pwedeng first step. Any suggestions? What could be my first major step here, aside from writing the assumptions? Can anyone suggest the line of action here? Okay, Charles. Yes, Matthew.
Sir, pwede ba yung parang gamitin yung A8? Yung existence of multiplicative inverse of A.
Okay,
Pwede ba yun agad yan, sir?
Right, pwede mo siyang gamitin. So, okay, moreover, AC equals C. Okay, siguro ilagay ko siya dito. Mukhang mas tama nga na unahin kong i-claim yung existence ng multiplicative inverse. Para kanino? Matthew, para nga kanino ko siya gustong gamitin?
For C po.
All right, for C. And I am sure that there exists a multiplicative inverse for C. Bakit?
Dahil dun sa existence of yun ba, sir? Dahil sa existence ng multiplicative inverse of C.
Pero hindi lahat ng real numbers may multiplicative
kasi sir,
inverse.
We know that C is a non-zero real number.
Okay, great. That's it. That's one thing that probably I'm gonna look for in your proofs. Okay, kasi hindi lahat ng real number ay merong multiplicative inverse. So before you appeal to a what is that? To that axiom, kailangan niyo sabihin muna na meron siya, sure ako na may mag-exist kasi nga siya ay non-zero, right? So by ano ang number yan? I think A8.
8, sir.
There exists a real number C such that ay yung mga bago pala dito sa mga klase ko. Mahilig ako sa mga symbols. For instance, this guy is such that, okay? Minsan ST yung ginagamit ko, minsan ito. Ito ay there exists, ano naman yan, commonly used yan. Ito ay bihira yung mga gumagamit, kasi siguro mahirap kasi siyang i-latex, pero yung mga lumang books, ganito rin yung ginagamit. So, saka mukhang matalino kapag yun ang ginamit ko. So, kaya siya yung gamitin ko. Such that CC inverse is equal to the multiplicative inverse, multiplicative identity. All right? And then so yun, nagamit ko na yung A8. Tapos bakit gusto nga ni Matthew na gumamit ng A8? And I think that is answered by Charles in the comments or in the chat box na kasi gusto kong mag-appeal ng multiplication property. Kasi meron na ako ditong equation, all right? Tapos kakaunti pa lang yung mga theorems at axioms natin. So kakaunti pa lang yung pamimilian na pwede kong gamitin. All right? And yeah, he's right. I'm going to use the multiplication property by multiplying both sides of this equation by C inverse. Kaya ako sinabi sa unahan pa lang nag-exist si C inverse para ma-justify na pwede ako mag-multiply ng C inverse both sides. Okay? So now, I'll be careful here, at least for now, na i-group ko muna si AC. Kasi nga si multiplication ay binary operation. So dapat 2 at a time lang yung pinagmo-multiply ko. Alright? So that's why I write it this way, equals quantity BC equals C inverse. Sorry, but may equals. So C inverse by MPE, multiplication property of equality. Alright? And then what's next? Anong susunod kong gagawin? Anyone? A6, ano ang A6? Ang A6 ay associativity. Tama? So thank you, Nerissa. That's right. I'm going to use associativity here. I mean, I will just reorder the operations or regroup the real numbers under multiplication. So I'm going to write it as A times CC inverse equals B times CC inverse by associativity of multiplication. Okay? Next, anong susunod? Susunod ko palang dapat gawin, magtimpla ng kape. Bigla ako naghanap ng kape. But anyway, what's next in the proof? Okay, Jonathan, that's right. I'm gonna use the property of multiplicative inverse. Kasi nga, yung C to the negative 1, notation lang natin yan sa multiplicative inverse. Meaning kapag yung real number na pinangalanan nating C inverse, minultiply ko siya kay C, ang sagot lagi ay multiplicative identity. So here, I can say this is A times 1 equals, the same thing will happen to the left side, to the right side. This would be B times 1. You can say by property of multiplicative inverses, or you can say by A6. All right, so A6 nga ba niya? A8. So pwedeng ganun nyo siya isulat. And then finally, last step in the proof. Pusin na natin itong theorem 1 point. Yeah. Okay. Thank you, Alex and Gian. And I think yan din yung sasabihin ni, kalimutan ko sino nagtaas na kamay. Yeah, I think this is A7 property of multiplicative identity. 1 multiplied to any real number will give us the original number back. All right. So this is going to be A equals B by A7 nga ba? All right. And again, and the proof. Napakita na natin, coming from the assumptions, right? Itong dalawang assumptions na to, they led us through logical arguments that A is equal to B, okay? And then so from now on, whenever you're dealt with a statement with this, like this, you can conveniently say, by cancellation law, A is equal to B. All right? And that's a nice exercise on direct proofs, right? Or conditional proofs. Okay. Any questions? All right. So kung wala, let's move on and look at some more consequences of the field axioms. So there are a bunch of them in theorem 1.3. And some of these are seemingly very naive, very elementary. Ito yung mga alam na natin, ginagamit natin ever since. But iba yung perspective natin ngayon. Remember, we don't know how to add, how to multiply, all right? Ang alam lang natin yung mga properties. We don't even know real numbers pa. Dadalawa pa lang yung real number na nakilala natin, si 0 at saka si 1. Okay? Lahat ay abstract objects. We're dealing with arbitrary real numbers, ino-operate natin sila, alam natin yung properties. Okay? Now, for instance, theorem part 1, it says that a times 0 is equal to 0. We know this since the time that we have seen a multiplication table. Hindi ko alam kung naabutan nyo pa nung elementary, yung mga notebook, merong printed multiplication table sa likod, dun sa likod, no, sa back cover. But, or ano na ba kayo? Calculator era na kayo. Pero anyway, so alam na natin yan since we learned how to multiply. But again, so Math 155, hindi tayo marunong mag-multiply pa. Alam natin yung properties ng multiplication or ano yung ideal properties parang isang operation matawag na multiplication. All right? But we don't know specifically how to multiply two real numbers. But property number 1 is telling us that when you multiply the additive identity to any real number A, you'll get the additive identity back. All right? So ito naman yung effect ng pagmumultiply ng additive identity sa kahit anong real number. Nagiging ang sagot o yung product ay yung additive identity pa rin. Okay? Now, this seems obvious because we know this from before. Pero nangyari yon kasi nga gusto nating ma-preserve yung sum na property so far ng set of real numbers together with addition and multiplication. So kaya kailangan ko siyang i-prove. And usually, mahirap i-prove yung mga obvious na bagay. Or kasi may bias tayo eh. Alam na natin to, napaka-simple nito. Alam na natin to since elementary days. Ang problema, paano natin i-prove yung isang bagay na tinreat natin as a gospel truth since we were young. All right? And this is a bit of a challenge, but let's try our best to write a proof for this property. Okay? Now, this is an identity. So we want to prove this identity. An identity is an equation that is true for a set of arbitrary numbers. Okay? So, pag nagpo-prove kayo ng identity, dapat lagi kayo mag-start sa isang side lang ng equation. Or the conventional way is to start with one side of the equation and deduce the other side. Okay? Through logical arguments. Now, nung high school ako, and I don't know kung na-experience nyo pa rin to, hopefully not, minsan sa trigonometry, nag-start kami rito, tapos gusto namin makarating sa isang statement, halimbawa 1 equals 1. Tapos check ka namin yung equal sign. Well, formally, it is not a good proof, all right? It does the job, it justifies that the statement, that the identity is true, pero hindi siya mathematically sound yung pagkakasulat ng argument. Kasi sa logic, bawal mong gamitin ang isang statement na hindi mo pa na-prove. And it is a cardinal sin to use what you want to prove in your proof, specifically to start the proof. It's just like saying na, okay, papatunayan ko sa'yo na totoo si property P. So dahil totoo si property P, blah, blah, blah. And you see, pag binerbalize nyo, you will spot the big mistake there. Hindi mo pwedeng gamitin ang isang statement para i-prove ang sarili niya. All right? And that's what you do whenever you write something on a proof. In a proof, unless you say that is assumed for the sake of contradiction, pag sinulat mo siya sa proof, dapat sure ka na totoo. So hindi natin pwedeng isulat sa proof natin na a times 0 is equal to 0 because we don't know if that is true yet. Yun nga yung gusto nating ipakita eh. So again, the conventional way of doing that, start from one side. And usually we start with the more complicated side. Okay? Kasi mahirap magsimula dun sa napakasimple na, tapos papakomplikaduhin ko siya. So mas madali, mag-start ka dun sa komplikado, try to simplify it using the properties that you have already proven para maka-arrive dun sa simpler side ng equation. Okay? But if you're good, you can start with a simpler one and then try to complicate it to go to the other or to reach the other side of the equation. Okay? So here I'm gonna let A to be any real number. Okay? And then we'll see what we can do with A times 0. The goal is to show that this is equal to 0 using logical arguments and the axioms or the theorems that we have stated before. Okay? Now, any suggestions? Ano kaya yung pwede kong gawin dito? A times 0 equals. Ito yung sinasabi ko kanina na parang hirap mag-isip ng paraan kung paano isulat si A times 0 when all our lives, lagi na lang nating, automatic sa atin ng A times 0 ay equal kay 0. Okay? But can you think of another way on how to write A times 0 that will bring us closer to the right hand side, which is 0? Existence ng multiplicative inverse. I don't think we can use that, Charles, at this point kasi nga hindi ko pa alam na si A times 0 kung siya ay kung nag-exist yung multiplicative inverse niya. Or if you're referring to multiplicative inverse ni A, hindi ako sure na nag-exist yung multiplicative inverse ni A. Kasi hindi ko alam kung si A ay non-zero or hindi. Remember, the only assumption here is that A is a real number. I don't know if A is non-zero. And then I will have a problem kung alam ko man na si A ay non-zero, kakaroon pa rin ako ng problema. Bakit? Kasi sige, assume natin ay non-zero siya. So meron siyang multiplicative inverse. Then I'm gonna multiply both sides by the multiplicative inverse. Or actually, wala pala akong paglalagyan kasi wala nga pala akong equation. All right? So that would be a problem there. Okay? But nice try though. Any other suggestion? Ito yung isang instance na kailangan mo maging creative. Kailangan mo mag-construct, maghanap ng isang specific way of rewriting A times 0, not violating any of the rules before or without introducing any outside assumptions. Okay? Paano ko siya masusulat? Si Luis, sabi niya ay 0 times A. So magmumultiply ako ng A. Kaya lang ang problema ay wala akong equation. I think Luis is suggesting gumamit ng APE or something like that. Ang problema kasi yung APE, dapat meron akong equation in the beginning. Problema ko rito, wala akong equation. Alright? May nagtaas ng kamay pero binaba. Hindi ko tuloy nakuha kung sino yan. Yes, Matthew?
Sir, pwede bang can we make 0 parang halimbawa, can we assume it to be like suppose B plus yung negative inverse ng B. Ay, yung additive inverse ng B. So like A plus inverse of B. Ay, B plus inverse of B. Yan. Ganyan, sir.
Alright. Something like that. Okay.
Yes po.
And then, anong pwede kong gawing susunod? Sorry. Times pala to, no?
Yes po. Pwedeng i-distribute.
Alright.
Yung,
okay, that's fine.
A to B.
Tama. So maging A times B plus A times negative B.
Yes,
What
po,
then?
sir?
Anong susunod?
Anong dapat 0?
Okay. Pangarap natin mapakita yan ay 0. Pero paano ko siya mapapakita na 0? Actually, tanda ko tong proof na to kasi last semester, nag-impromptu proving ako nito. Tapos, ito yung una ko naisip na gawin. Kaya lang, napatigil ako sa step na to. Alright? Napatigil ako.
Okay, sige po, sir.
Sige.
Go ahead, sir. Okay na, sir. Medyo stuck na rin ako.
Right. Dito ako na-stuck for 5 or 10 minutes na, hindi naman 5 to 10. Na-stuck ako kasi, ito yung nasa isip kong proof, sinulat ko na siya, pinersend ko siya sa klase. Tapos, na-stuck ako. Wala na akong pwedeng magawa rito. Kaya tama, Matthew, na ma-stuck ka talaga. Kasi, alam ko kasi at the back of my mind, yung A times the additive inverse of B, alam ko siya ay negative AB. And then AB plus negative AB by A4 ay equal kay 0. then that should have been the end of the story. However, hindi ko pa na-prove na yung A times additive inverse ni B ay equal sa additive inverse ni AB. And that will fall under what? Actually, wala pa nga siya dun sa mga theorem. Alright, na ang A times additive inverse of negative B ay equal kay additive inverse of negative B. Because insofar as our development is concerned, yung A times negative B ay hindi pa natin alam kung siya ay equal kay negative AB. Because these two things speak of two different operations or may dalawang prosesong meron dalawang magkaibang prosesong nangyayari sa dalawang bagay na ito. But again, our bias from elementary na, sir, equal yan. Pero yun nga, wala tayong proof na equal silang dalawa kasi ito nga ay A times additive inverse ni B. Samantalang ito, siya yung additive inverse ng AB. So nag-multiply muna ako ng A at saka B, saka ako kinuha yung additive inverse niya. Ito, minumultiply ko si A sa additive inverse niya. So that's why you will really get stuck kapag ka ito yung ginamit natin sa proof. Alright? I saw Anna raising her hand earlier. Anna, you want to say something or add something to the discussion?
Sir, can we add A minus A?
Come again, sorry.
Can we add A minus A sa A times 0?
All right, so A times 0 equals A times 0 plus A minus plus negative A.
Yes po.
All right. Yeah, we can do that. Kasi nga, yung A plus negative A, alam natin, equal lang yan kay 0. And 0 is the additive identity. So adding 0 or something equal to 0 will not change the given quantity. So that's fine. And then I guess what you want to do here next is to what?
Distribute po.
Distribute what over what? Kasi ngayon, puro addition pa lang to eh. Tama? So, or gusto mo mag-grouping muna? Pwede ako mag-associativity muna. Tama ba? Yeah. Kaya lang feeling ko magkakaproblema pa rin ako dito nung pagfa-factor naman ng -1 or paggamit ng distributive property kay -1 because we haven't proven yet na kapag ka meron kang negative A, equal yon kay -1 times A. Right? Yun pa lang yung theorem number 3. Kaya medyo hindi ko rin pwedeng magamit to. I think hindi ko pa rin to pwedeng magamit unless Anna you're thinking of another clever way of writing this. Pero I think there would be a little bit of a problem there. Okay.
Yun din po sir, iniisip ko yung -1 pero hindi pa pala siya proven.
Oo, so yun yung mahirap, no? Yung bias natin before na may bumubulong sa atin. Hindi pala bumubulong. May sumisigaw na pwede mo tong gawin. Pero kasi yun yung natutunan natin before, may meta-axiom of ignorance. So hindi natin siya pwedeng gamitin. Alright? But those are good suggestions. That's nice. Keep them coming para malalaman natin kung tama ba yung iniisip natin. Okay. Gian is asking, can we assume po na A is not equal to 0? Kung yun lang, hindi natin siya pwedeng i-assume Gian kasi sabi sa problem ay si A ay real number. That's the only thing we know. But if you have thought of a way to prove the statement kapag ka si A ay non-zero, okay lang. Kaya lang, kailangan mo mag-prove kailangan mong i-prove yung case kapag ka si A equal kay 0. So that means you have to break the proof down into two cases. The first is assuming A is not equal to 0, you can write your proof assuming that A is not equal to 0, but you also need to provide another proof or another paragraph in your proof that will handle the case that is A equals 0. All right, so parang siya naman yung breaking down a theorem into several cases, which could be fine, kaya lang kailangan mong i-prove na totoo siya sa lahat ng possible cases. Okay? Now, all right. So, I think meron mga nag-comment or nagsuggest sa chat box, Gian, Charles, and Nerissa. I think ultimately your suggestions are similar to each other, and I think that's the nice route to take here. So out of the blue, I will write 0 as 0 plus 0. So sulat ko yung A. I'll just copy A. Kaya lang yung 0, isusulat ko siya na 0 plus 0. Okay? And I can do that since 0 is the additive identity. Additive identity. Right? Yung pala, pag nagsusulat ako sa discussion ng proof, usually may mga abbreviations akong gagamitin. Kapag kayo, kailangan yung isulat siya ng buo unless accepted or conventional acronym siya. Halimbawa, APE. Pwede niyo sabihin APE. I will get what you mean by APE. Yung mga hindi familiar abbreviations, paki-spell out na lang. Halimbawa yung AI, hindi siya usual abbreviation for additive identity. Pero pwede ko siyang gamitin kasi nagsasalita ako. Na-explain ko verbally ano yung ibig sabihin ng sinulat ko. Kaya lang kayo, pag nagpasa kayo ng homework, written lang lahat, wala kayo sa tabi ko pag nag-check para sabihin na, oh, sir, yung AI, additive identity yan. So, paki-spell out na lang nung mga ganung bagay. Okay? Now, it seems to be very out of the blue. Bakit isusulat ko si 0 na 0 plus 0 of the different ways on how to express 0 or to express 8 times 0. Ito yung napili kong gamitin. Alright, makikita natin siya later, pero ito yung sinasabi ko na parang sa analysis laging may construction na nagaganap. Parang meron tayong kinonjure out of thin air na isang bagay para gamitin sa proof. Okay? So usually nanggagaling siya sa preliminary analysis or just very creative forward thinking. Okay? Pero bakit ko siya napili? Kasi at this point, pwede akong gumamit ng A9, distributive property of addition over multiplication or multiplication over addition. So I'll have A times 0 ay equal kay A times 0 plus A times 0 by A9. Okay? And then, susulat ko to ng ganito. 0 plus A times 0 equal kay A times 0 plus A times 0 by what? What's the property I used here in the newest line? Bakit ko siya sineset up ng ganyan? Though pwede ko naman siyang hindi daanan, pero para mas clear, ginawa ko siya. And Charles is right. This is the existence or the property of additive identity, right? So, ika-copy-paste ko lang itong reason na to. Okay, copy. All right. So again, 0 is the additive identity. So I can add it to anything without changing or without affecting the equation, right? Sinulat ko siya, sinet up ko siyang ganyan para magamit ko yung addition cancellation law. Alright? Kasi meron akong dalawang equal na bagay. Alright? Tapos, magkaparehas yung inad ko sa kanilang dalawa. Okay? Sabi ng addition property, cancellation law for addition, if you have A plus B ay equal ka, A plus C ay equal kay B plus C, then A is equal to B. This is my A, this is my C, this is my B, this is my C, parehas na may C na naka-add, so I can just use the cancellation law, all right? And ultimately get A equals A times 0 equals A times 0 by the cancellation law for addition. So CLA, hindi rin siya common abbreviation, but I can explain to you na siya ay cancellation law for addition, okay? And then I'll use the symmetry of equality to rewrite this as A times 0 equals 0 to perfectly match the statement in Theorem 1.3. And again, there you go, our black box. Okay, so from now on, hindi na natin, pwede na natin gamitin ng A times 0 ay 0. Hindi na natin kailangang awayan yung teacher natin ng elementary kung bakit nga ba ang A times 0 ay equal kay 0. All right? Of course, there are several other ways that you can do it. If you are at this line, okay, dun sa na-highlight na line, pwede ka na lang diyang mag-add ng negative A times 0. Or pwede mong i-add to both sides of that highlighted equation the additive inverse of A times 0. Right? Dahil alam naman natin si A times 0 ay real number, so meron siyang additive inverse. Tawagin natin yung additive inverse niya na negative A times 0. Add mo siya sa both sides, magzi-zero to. Kasi magkakaroon ka ng A times 0 plus the additive inverse of A times 0. You will end up here. Pero to make it fancier, I use the cancellation law for addition instead. But of course, there are several ways to kill a cat. So kayo na yung bahala kung ano yung mas komportableng pagsulat ng proof. Okay? Is that good? Any questions? Okay, so if there are none, let's try to answer another one. Probably let's answer number 2. Okay. Right. Yung statement number 2 is negative of negative A equals A. Again, napakalaki ng chance na ma-overcome tayo nung bias natin. I mean, the information that we know before. In this case, you probably will think of at first that this statement is telling us that a multiplication by a negative sign to negative A will give us A, or multiplying negative 1 to negative A will give us A. But again, we don't know how to multiply yet. Kasi nga, hindi pa nga natin kilala lahat ng mga real numbers at hindi tayo tinuruan ng multiplication except yung mga properties ng multiplication. Yung mismong pag-carry out ng process, hindi pa natin alam. So the way to address statement number 2 is to think of it in terms of the notation and the language that we have developed so far. Now, if you will read the left-hand side, this is not negative of negative A or negative times negative A because multiplication of specific numbers doesn't make sense to us yet. All right. But this guy is what? This is the additive inverse. Remember, a negative sign preceding a real number means it's the additive inverse of the following number. All right. So this guy is the additive inverse of the additive inverse of negative A. All right. So ganun nyo siya tingnan. Additive inverse ng additive inverse ni A. And we want to prove that the additive inverse of the additive inverse of A is equal to A. Right? So yun yung gusto nating i-prove. So basically, gusto nating i-prove yung pagiging additive inverses ng dalawang bagay. Namely, si A at saka si negative A. Alright? So, paano ko mapapakita na sila ay additive inverses ng isa't isa? Well, I can write the proof this way. So I'm gonna let A to be any real number para clear na hindi ko kailangan maghati ng cases. Then I will investigate what happens to A when I add to it negative A. Alright? Kasi nga ang claim dito, ang additive inverse ng additive inverse ni A ay si A itself. So I want to test that hypothesis. Totoo ba yun? So si A nga ba ang additive inverse ng additive inverse ni A? Siguro ganito ko siya dapat pala isulat kasi I'm looking for ano yung additive inverse ni negative A. Ang claim ng theorem, ang additive inverse ni negative A ay si A daw. Para makita ko kung totoo yun, so i-add ko si A dun sa kiniklaim na additive inverse niya. Alright? Or i-add si A doon sa additive inverse ni A. Because again, I'm claiming here na additive inverse ni negative A ay si A. So para mapurbahan kung totoo yun, i-add ko nga si negative A at saka si A. Kung si A nga, yung additive inverse ni negative A, ano dapat yung sagot dito? Anyone? Pag pinakita ko kasi yung proof, one-liner lang yan eh. Kaya lang ang daming nangyayari dun sa one-liner na yun. Kaya kailangan ko siyang i-explain step by step or letter by letter, character by character. Yeah, Charles is correct. Ang sagot dapat ay 0. Parang isang number, masabi mo na additive inverse siya ng isang number, dapat pag pinag-add mo yung dalawang numbers na yun, ang sagot ay 0. Again, Theorem 2 or Theorem 1.3.2 is telling us to prove that the additive inverse of the additive inverse of A is equal to A. So para masabi yon, kailangan kong i-add yung additive inverse ni A kay A and hope that the answer is equal to 0. Okay? But that's easy kasi gagamit lang ako ng commutativity. Pwede ko itong masulat as A plus negative A by commutativity A1, commutativity of addition. And then this is equal to 0 by A4, property of multiplicative inverses. Okay? And now, what do we have here? We know that negative A plus A ay equal kay 0. Nagsi-0 lang ang sum kapag ka additive inverses yung pinag-add ko. So therefore, I can conclude that the additive inverse of negative A, meaning what is to be added to negative A to get 0, is exactly the number A. And that ends the proof. Imagine kung ito lang yung nakita nyo, you will think that the proof is nonsense or it's very basic na kailangan pa bang isulat yan? Pero once you analyze the essence or the spirit of the letter, makikita nyo na ganito pala yung nangyari. It's a play on the definition of additive inverses. All right? So any questions with that? Okay, no clarificatory questions? Now, according to our course timetable, we should have a homework due on Monday, all right? So I'll give you the option among these, the remaining 5 theorems. Sige, remaining 4. Pili kayo dito, 4 to 7. Ano yung gusto nyong i-prove? Sige, habang nag-iisip kayo, si Gian may tanong. Last part ng after ng equal kay 0 by A4. So, eto, paano nakuha yung conclusion? Tama ba, Gian? Okay, so paano nakuha yung conclusion after nung by A4? Well, ang nakuha natin dito ay negative A plus A. Meaning, pag inad ko daw si A kay additive inverse ni A, ay nakukuha ko ay 0. Remember, nakukuha lang natin si 0 as a result of addition kapag ka ang pinag-add ko ay mga additive inverses ng isa't isa. Alright? So that means since negative A plus 0 turns out to be equal to 0, that means these two guys are additive inverses of each other. Or in other words, I can say that the additive inverse of negative A is equal to A. Because when I add them together, I'm going to get the additive identity back, right? So ang additive inverse ni negative A ay equal kay A. Alright? Good? Tapos ngayon, isi-symbolize ko siya. How do I say or how do I write na ang additive inverse ni negative A ay si A? Well, ang additive inverse ni negative A ay equal kay A. So, yun, it's just a tricky play on the definition of additive inverses. Okay? So I hope that clears things up, Gian. All right, so medyo kaya gusto ko i-discuss tong proof na to kasi one-liner, kaya lang siya, medyo mind twister yung argumentation, okay? All right, so what do you want to have to be your homework number 1? By the way, homework number 1 is due on the 28th. That's Monday, right before midnight on Canvas. So ano yung gusto niyo unang homework? 4, 5, 6, or 7. Write a proof for any of those. Okay, pag wala nag-suggest at the count of 3, ako yung pipili. 1, 2, 3. So for you guys, dahil walang pumili, your homework would be number 6. Try. Sige, number 4 na lang pala. Sorry. Number 4 na lang. Baka magtampo kayo kasi baka mas mahaba kasi yung proof ng 6. Not necessarily mas mahirap, pero mas mahaba kesa dun sa proofs nung 4 and 5. Sa kabilang section 5 yung pinili nila. So siguro sa inyo, number 4 na lang. So that would be your homework due on the 28th. Right after this call, I'm gonna upload sa Canvas yung questionnaire para sa homework. But essentially, that will contain a proof of number 4, plus I'll ask you about how you are doing the first week of classes para sa remaining points. So this will be worth 4 points. Tapos yung chika question ay worth 1 1.25 points for a total of 5.25 over 5. So meron kayong 5% bonus sa homework number 1. Just answer that Chica question, okay? All right, so okay, so good luck on the first homework. Now let's move on. 10 minutes na lang, pero gusto kong habulin yung kabilang section, so probably mangungutang ako sa inyo ng 5 minutes. We'll end at 3:55. But let's pick up the pace a little bit. Just let me know kung masyadong mabilis. So remark 1.2, dinefine lang natin yung exponentiation. All right? Kasi nga dapat axiomatic tayo dito, true to the letter of axiomatization. So kapag nakakita kayo ng x to the power 2 where x is a real number, that just means we need to multiply x to itself. And we'll have as many factors as the exponents. So x squared is x times x cubed is x times x times x, and so on. And that will work for any natural number, okay? Now, whenever you have a negative exponent, so kung strict kayo, sir, ano yan eh? X raised to the additive inverse of 2. That's right. But how do we interpret that? Well, we can interpret it as the multiplicative inverse of x raised to the second power. Okay? Kasi gusto kong i-take advantage yung pagkaka-define ko ng kapag ka ang exponent ay natural number, kaya lang may negative to. So, by our convention, this is what we mean by x to the negative 2. It is the multiplicative inverse of x raised to the second power. And by the previous definition, how do we define the second power? That is just the additive inverse of x multiplied to itself twice. Okay? Or, kung meron kang x to the negative 5, so that will just be the product ng limang x to the negative 1s, or limang multiplicative inverses ni x. And then fractional exponents, usual radicals, yung definition. Okay, ganun natin sila i-define. So x to the 1/2 equals a if and only if a, when squared, is equal to x. All right? So, pero ito naman yung usual notations na alam natin from before. Kailangan ko lang siyang isulat para ma-maintain ko yung disguise na axiomatization. All right? Now, with that in mind, we can now meet ano nga ba yung itsura ng mga real numbers. Of course, there's another layer of theory behind the set of natural numbers, integers, or rational numbers, and a bunch of reasons why they are so. Halimbawa, sa construction ng natural numbers, kung gusto niyo mag-stick talaga sa axiomatization, Piano's axiom, yung kailangan nyo para ma-construct yung natural number as the set containing 1, 2, and 3. Si 2 ay successor ni 1, si 3 ay successor ni 2, and so on. But that will be too much if we will try to rebuild everything from scratch. Saka hindi na siya yung focus ng Math 155. Probably the axiomatic development of n, nakita nyo na yan dapat sa Math 101, or you will be doing it in Math 103. But for us, for the sake of brevity, assume na lang natin, set of natural numbers, ang laman niya ay 1, 2, 3, 4, 5, and so on. Okay? Dun sa mga estudyante ko ng 101 last semester, medyo iba yung n natin ngayon sa 155, hindi ko sinasama si 0. Sa 101 kasi namin last semester, sinama ko si 0. But for now, let's not include 0 in the mix. Z is the set of integers, okay? And it is denoted by the letter Z, the double struct Z. And it is the natural numbers together with their additive inverses, which we will call the negative numbers. Sorry, hindi ko pa pala pwedeng banggitin yung negative numbers. Hindi ko pa i-define yung negative. So, mga natural numbers together with their additive inverses at saka si 0. They will constitute the integers. And then the set of irrational numbers will be all numbers that can be written as a real number times the multiplicative inverse of another real number. So sila yung magko-constitute ng mga fractions. Remember how we defined a fraction earlier or division earlier? A times B is A divided by B is equal to A over B, which is A times the multiplicative inverse of B. So any number that can be written as a real number, not a real number, an integer times the multiplicative inverse of another integer, then that is a rational number. And all numbers that are not rational is an irrational number. So ito yung mga numbers na assume natin na kilala na natin ngayon. So ito yung mga subsets ni R na alam natin. Set of irrationals, i-denote natin siya by Q complement or Q upper C. Okay? Siya yung gagamitin kong symbol para sa complementation. And let's do that for the entirety of Math 155 because I'm gonna using prime as for another set. Yung iba kasing logic books or set theory books, yung complement ng isang set, nilalagyan lang nila ng apostrophe o ng prime sa dulo. So for them, the set of irrationals is Q prime. But I will be using prime for another notation later. So let's stick to using a superscript C para sa complement. Okay? And then dito ko sana gusto magtapos kaya lang we're running out of time. I don't know if I can finish it in 5 or 10 minutes. Hopefully I can. If you need to go by 3:50, then please do so. Kung may klase kayo after, but if you don't have anything to do, so you can stay with me. Tapusin natin yung proof ng theorem 1.4. Okay? There's a rich history behind this square root of 2 being irrational. Being irrational. Because to Pythagoreans in particular, and probably the early civilizations, numbers are mystique. Numbers are divine. They are treated to have an out of this world or a spiritual sense. All right. So kaya napaka-laking deal sa kanila nung construction o nung structure ng mga numbers, especially the Pythagoreans. And for a very long time, centuries or even millennia, people thought that all numbers can be written as a ratio of two integers. I mean that everything is rational. And it is not until the Pythagoreans or the Pythagorean school that people discovered or formally discovered and accepted that there are numbers that cannot be written as a ratio of two integers. Ang example nga ay yung square root of 2, the famous square root of 2. Now, some early civilizations might have known that there are irrational numbers like e, square root of 7, square root of 5, but the discovery of irrational numbers is often attributed mainly to the Pythagoreans kasi sila yung may systematic way of writing things. So meron silang mathematical system. Nag-axiomatize sila. So kaya nilang i-prove for certain in writing na irrational talaga yung mga numbers na yun. And the story behind this is, legend says, so legend lang daw to, it is the Pythagorean mathematician and philosopher Hippasus who discovered that square root of 2. Because prior to him, everyone believed that, or the Pythagoreans believed that every real number is rational. So yung square root of 2, hindi nga lang nila alam kung paano isulat as a ratio, pero inassume nila rational yan dapat. And this guy, Hippasus, provided a proof that square root of 2 is irrational. So according to legends, due to its discovery and the hesitance of the Pythagoreans to accept that, because it is counter to the gospel truth that they believed in, that everything is rational, ginawa nila, nilunod nila si Hippasus for the crime of spurting out and spreading the word that square root of 2 is irrational. Though sabi ng mga historians, hindi proven na ganun talaga, na si Hippasus yung dahilan ng square root of 2, or kung nilunod talaga ng mga Pythagoreans si Hippasus dahil doon. Pero there are records na meron talagang Pythagorean na nalunod or nilunod ng mga kasama niya. Kaya lang hindi ma-attribute historically or by documents na si Hippasus talaga yan. But that's a nice legend showing you how important numeration systems are to the Pythagoreans. Okay? Now, let's try to write a proof of it. So, try nating isulat yung proof niya. Add lang ako ng page. And let's show that this is indeed true, na irrational si Q. Kaya lang, dalawang parts yung proof kasi kailangan ko ng isang intermediate result bago ma-prove na si square root of 2 ay irrational. So, that claim is this. Okay? If A is in R, if A is a real number, and a squared is even, then a is even. Gagamitin ko to dun sa proof mamaya. Alright? Kaya lang, dahil hindi pa to na-prove, kailangan ko siyang i-prove muna bago ko siya magamit dun sa proof ng irrationality ng square root of 2. Alright? And then there are several ways on how to prove it. Kaya lang yung direct proof, katulad nung ginamit natin kanina, medyo mahirap siyang gamitin. Kasi imagine, if I will use a direct proof, ang mangyayari, ang assumption ko, a squared is even. Pero pag even si a squared, ibig sabihin si a squared, pwede kong masulat as 2p for some integer p, right? Definition ng pagiging even. Kaya lang, ang gusto kong i-prove ay si a ay even. So I need to know how a looks like, all right? But with only this information, that a squared is equal to twice p, then the only thing I can get from here is that a is equal to plus or minus the square root of 2p. But at this point, I am not certain, or there is no distinctive way to conclude na si a ay even. Kasi nga may square root na kasama, hindi ko alam kung kaya ko makapaglabas ng factor na 2 out of this square root. And then kung makapaglabas man ako ng 2 out of this square root, is the expression inside the square root that will be left, will that be a perfect square? So that's a big problem. So kaya yung direct proof, hindi siya madaling gamitin or hindi siya suggested gamitin para sa statement na to. Now, an alternative way is to prove the contrapositive. Kaya nga parang review nga to ng 101 eh. Ito kaya gusto ko tong first chapter na to or itong section na to. Now, proof by contradiction uses the fact that a conditional statement P implies Q is equivalent to not Q implying not P. Ang tawag natin dito ay contrapositive nitong statement na to, or it undergone contraposition. Okay? So, dahil sila ay logically equivalent, kung mapoprove natin yung not Q implying not P, then we will be able to conclude that P implying Q is also true. Okay? So here, we will do a proof by contraposition. Kasi mukhang mas madali itong gawin. Okay? Now, how will it go? Now, here we will assume, dahil proof by contraposition, hindi ko i-assume yung nasa if part. Kasi di ba P implying Q, direct proof, i-assume si P, ipakita si Q. Pero sa proof of contraposition, ang gusto nating gawa ng direct proof ay yung not Q implying not P. So ang i-assume ko ngayon o yung pagsisimula ng proof ko ay si not Q, which is the negation of the consequent. Ang consequent natin dito ay yung Q natin ay A is even. In the proof by contradiction, the assumption is the negation of the conclusion. So here I'm going to assume that A is not even, or in other words, A is odd. Okay? And we want to show, yung WTS, we want to show, yun yung abbreviation ko sa WTS, we want to show the negation of the premise. Okay? Gusto kong ipakita na not P, but our P here is A squared is even. So I want to show that the negation of that is true. So I want to show that A squared is odd. And you will see in a second why this is much easier than the direct proof. Okay? Now, our assumption, A is odd. So by assumption, we can say that A is equal to 2k plus 1 for some integer k. All right? Kasi nga, odd siya. Odd siya, even plus 1. Yun yung characterization ng mga odd numbers. So that's fine. And remember, our goal is to show that A squared is odd. Gusto ko makita ano yung itsura ni A squared. Now, I know how A looks like, so it is natural to just square both sides of the equation, and squaring both sides of an equation is tied or is founded on the multiplication property of equality. Kung meron kang dalawang equal na bagay, pwede ka mag-multiply sa kanilang dalawa ng equal na bagay din, you'll get equal products. So I'll multiply A by itself, and then I'll multiply 2k plus 1 by itself again, all right? And then I'll get the same thing, all right? Squaring both sides, in short. Tapos, gagamitin ko si special products. This is 4k squared plus 4k plus 1. All right? Algebra, special products. Okay? Tapos, anong gusto natin ipakita? A is odd. So I need to show this is of the form 2 plus another integer plus 1. Yun yung gusto nating ipakita para kay A squared. But that could easily be done by using the distributive property. Okay? Look at the first two terms. Meron silang mga 4 sa unahan. Ilabas ko lang yung 2. Right? And that is justified by A9, distributive property. Okay? Matitira si 2k squared plus 2k plus 1. Okay? By A9. All right. So now what do we get? Now we know that, we can conclude A squared is even. Kasi this, A squared is odd. And that is because this is 2 times another integer plus 1. So I'm sure that A is odd. So therefore, we are done. We have shown that if A is odd, then A squared is also odd. But it is equivalent to its contrapositive, which is actually what we wanted to prove. Therefore, we can conclude that A squared is even implies A is also even. End of proof. Okay? So ito yung alternative sa proof sa direct proof. Kung mahirap yung direct proof, try nyo i-prove yung contrapositive. Okay? And that's what it is. Since we don't have time, so next time, ipoprove na natin yung promise, yung main result ng square root of 2i irrational. And there we will meet again another powerful proof technique. Yun naman yung reductio ad absurdum. Gusto kong sabihin yung reductio ad absurdum kasi it's so Harry Potter-like, no? But anyway, that's proof by contradiction. And we'll do that next time. Right? Any questions? Bilis ng oras. Okay, but I think we can stop here. It's a good time to pause. Don't forget homework number 1. I-upload ko mamaya yung formal questionnaires sa Canvas. Deadline is on Monday right before midnight. And then I think the consent form is also due on Monday right before midnight as well. So don't forget, that's easy, 5 points. Just sign the paper, tick the boxes, then that's 5 points. Bonus points nga pala yon, so tatanggalin ko yung denominator niya later. So make sure you do that. Sayang yung plus 5. Tapos ito, merong bonus question na 1 point, hindi pala. May 0.25 na bonus pag sinagutan yung how are you question dun sa homework 1. Okay, so if there are no questions, then thank you for giving me 7 more minutes than scheduled. So I hope you guys enjoy the rest of the day. Enjoy the holiday. So it's a long weekend. And let's see each other again on Tuesday. Bye, everyone. Oh, by the way, yung mga nag-recite nga pala verbally, pa-comment naman yung yung nicknames nyo dun sa chat box para ma-record ko yung mga nag-recite. Yung mga nag-recite ng puro text lang, that's fine. Mababasa ko naman yung chat box later. Okay? So bye guys. See you on Tuesday.